Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss one very important concept related to glue crawling. Okay, what is crawler, what is glue catalog, what is glue job, right? All these things I have covered in my previous videos in detail. If you want to know those detailed explanation, then please go through the link given in the description box, because that particular concept surely help you to understand today's discussion in a better way. Okay. So today what I am going to cover? Today I am going to discuss about incremental crawling. Okay. So what is incremental crawling? Let us try to understand. Okay. So generally any glue ETL pipeline looks like this. We are having our source system that can Redshift or S3 or RDS or database running in EC2 instance. We basically connect our glue crawler with the source systems, and the crawler basically crawl the source system and try to invert the schema, and that it populate in the glue catalog, right? Glue catalog is basically nothing but database and table, which we can take in Amazon Athena for running serverless ad hoc queries, or we can read the data in Amazon Redshift using that, or nowadays even we can connect Amazon EMR with the glue catalog. We can treat that as external Hive meta store, and then we can apply transformation by fetching the data from glue catalog. Or even we can directly take the data from glue catalog to our glue job in our ETL pipeline, and then we can apply necessary transformations and business logic implementation we can do on that, right? And then maybe at the end of the day, we can build some beautiful data visualization using Amazon QuickSight or other BI tools like Power BI and all, right? So this is what is about our general flow related to glue pipeline, correct? Now, let us try to understand some optimization, okay? Suppose you are having a huge volume of data in your data lake, okay? And suppose every day before starting the actual glue job or EMR job, you are making sure all the partitions are up to date in glue catalog, or if in data lake new column is added or schema changes, then that should be getting reflected in glue catalog. For those kind of events, if you want to make sure that your glue catalog is up to date with respect to your S3 data lake data, then before starting your actual pipeline, first you have to run the crawler, right? Crawler will crawl the source system, that can be our data lake in this particular discussion, and then it will update the catalog, right? It can do schema evaluation and all these things I have already covered, right? Now you just think, suppose you are working in a particular scenario where you know that the data from the source system, whatever coming in S3, that is always going to be incremental data. Okay, that is always new data will be appended in new files, like that it will be going. Suppose you know that, okay? Then before starting glue job, if you every day schedule the glue crawler to run first, then if it scan the complete data in S3, eventually that will be a huge volume of data, and your glue crawler will take time to crawl the complete dataset, and obviously the cost will also increase, okay? But if you know that the new data is coming as new files only, then in that kind of scenario, you can only crawl the latest data or the incremental data whatever came in S3, right? You no need to crawl the older data, because older data is not going to be changed. Whatever new ingestion happening, that are coming as new files, right? So in that case, to update the glue catalog, you can run the glue crawler only on the incremental files instead of running on the all files, okay? And that way, crawler will take less time to crawl the data, because incremental data will not be very huge, and obviously that will save cost, as well as that will improve the overall pipeline timing. From the performance wise also it will be faster, right? So now the question is how we can make sure that the glue crawler is running only on the incremental data, it is not running on the whole data, okay? That's what today's discussion topic, that is how to set up incremental crawling using Amazon S3 event notification, okay? Let's try to understand that, right? So I hope what we are going to discuss, that is pretty much clear. So here, like I have written, when you schedule a crawler to discover the data in Amazon S3, you can choose to crawl all folders or crawl new folders only, okay? If you choose to crawl all the folders, then basically it will take more time, and if you are sure that only new data is coming as new files in your S3 data lake, then you can only crawl the new folders. You no need to crawl the older folders already which you have crawled, right? So that is what incremental crawling. So let's see how we can implement that. Okay. So incremental crawling looks like this. It might appear a bit complex, but actually it is very simple. What happens? This is our S3 data lake where new files are coming in new folder location, and every time suppose new files are coming, we can create an event notification. One event will be getting published in the Amazon SQS queue. Okay, using proper access policy configuration, we can make sure that the S3 can publish the event to SQS queue. Okay, and then we are having our glue crawler here. What the crawler will do, instead of crawling all the files in the S3 folder or in our data lake, it will just read the new files, whatever came in our S3 based on the event notification, whatever the SQS accumulated, and those files, those newly incremental files alone, it will be crawling. Okay, that crawl you can start from AWS Management Console directly, or you can schedule using rate or corn expression, or you can do using Lambda, using Python code API call also you can do. Okay, and after the crawler runs on the incremental files, it will update the glue catalog. Okay, that's the simple approach. And here you can see this particular crawler should have Amazon SQS policy, obviously, because it is going to read the latest information from SQS. Then S3 access also it should be having, because from S3 only it is finally going to crawl the data and populate in glue catalog. And obviously glue policy, there is glue service role default one, what we earlier also used, that one also it should be having. Okay, so this is pretty much about architecture. Now without any further delay, let us directly jump into the implementation section. Okay, so first step, what we are going to do, we are going to create a glue role, okay, which is having glue service role access, which is the default one we generally use, and SQS access and S3 access. Okay, you can check in the diagram also, these three access it should be having, right? Right. So first what I will do, I will go to AWS Management Console, and in here I will go to IAM. Okay, and then here I will create the role. So I will choose here glue. I'll go to next. First I'll be taking glue service role. Then I will give S3 access. As of now I am giving full access, but you can fine tune the access before moving to production. And also I am giving SQS access. That's pretty much it. I can go to next. Role name glue incremental YTD. Okay, I will be copying this one and I will be pasting that here. And these are the accesses what we are providing. We will create the role. Okay, first step is done. What is the next step? We are going to create an S3 bucket. Okay, this is the bucket. So here I will be going to AWS Management Console, and here I will go to S3. And then here I will create the bucket. Create the bucket. Okay, that's pretty much it. Now here we are going to create an SQS queue. Okay. So I'll be going to simple queue service. And then here as of now you can see no queue is there. I can create a queue, standard queue, demo glue incremental clock. Okay, that name I am giving, keeping default properties as of now. So what I will do, I will copy the CRN. Okay, now here we need to make sure in this SQS queue the policies are configured such that the S3 can publish the event in the SQS queue. As you can see in the diagram, S3 should be able to publish the event, as well as this glue crawler should be able to read the content from SQS queue. Okay, so here what we are going to do, here this is the policy what we have written. So as you can see here, person ID, like what we generally write, and then effect is allow, we want to allow. So what we want to allow, so the glue role whatever we have created, that should be allowed to perform SQS operations. Okay, so let me first take that one. So this is the role name. I'll be taking the role ARN from there. I've copied that. So as you can see, this particular glue role should able to access, or we have to allow them to perform all operations on SQS. Okay, so like if you consider this particular diagram, this particular glue crawler should able to read the notifications. Okay, and once it read the notification, it should be deleting those also, so that it will not be reprocessed. Okay, so there are a lot of permissions it needed. Individually I am not giving, rather than that I am giving all the operations. Okay, SQS star, and on which SQS we are going to provide, on that we are going to put the resource name, okay, for our SQS. So I'm going to take the resource name for SQS and I'm going to paste that. Okay, and apart from that, S3 should able to publish the event to SQS, right? So here the principal is S3, and the S3 should able to send message in SQS. So what should be the SQS ARN? That is basically this one only. I'll be taking that and paste that here. And what S3 bucket should able to publish the event? That is that particular S3 whatever we created. Okay, what is the bucket one? So I'll be just taking the bucket ARN, copy that and paste that here. Okay, super. And from which account that S3 bucket is belonging to, that also you need to provide. I'll be taking my account and I'll be pasting that. Okay, so this becomes our SQS role, okay, with respect to accessing as well as publishing message. So here I will edit this one, and here I'll be pasting the access policy, and I'll save that. Now we are all set. Okay, so that is done. Now what is the step 3? We are going to create event notification for S3. Okay, so the S3 should able to publish the events to SQS Glue. So for that we are going to properties in the bucket, and then here we are going to event notification, create event notification, event name, glue, data lake, new files, notification, send. Like that I can put, and all object create event I am putting. If you are suppose deleting some object from your ingestion process, then that time you can create the notification for all object delete event also. But generally in incremental condition, always we are going to append new files. Generally we don't delete, so I am putting all of the create event. Okay, and then here to which component we should be sending notification, that is SQS, right? So this is the one, and I will save the changes, right? So here you can see in the event notification our this S3 event notification is added. Perfect, right? Now what we are going to do, we are going to unload the data from Snowflake. But before that, we are going to create the glue crawler. Okay, this particular crawler we will be creating, which will basically always read the files which has to be crawled from the SQS queue. Okay, and then we will upload the data in the bucket. Okay, so here I'll be going to AWS Glue. And then here I am going to crawlers, and I am going to create a crawler. Okay, so add crawler. Crawler name I can put demo glue incremental. I will go to next, and then here you can see that the source is data source fine. Here one option you are getting, right? Crawl the changed folders identified by Amazon S3 event notification. So that one we have to select. Okay, I'll go to next. Then connection no need to put. What is the source? So that source is basically this particular bucket, right? So I'm going to choose that one. I can put one more slash, so inside this data should be coming, right? Include SQS ARN. So SQS queue we have created, right? That ARN we have to paste. Simple. Okay, so generally whenever we are working with SQS, then we configure date letter queue also, which will capture the unprocessed message. But as of now I'm not keeping that. If you want, before moving ahead to production, you can create that one also. I'll go to next, and I will choose an existing IAM role, whatever we created. The role name what we created is glue incremental demo, right? So I'll be choosing that, this one, right? I'll go to next, and frequency run on demand is fine. If you want, you can configure hourly, daily, or you can trigger from Lambda. All these activities you can do. I'm not going to that. Then here add database. Okay, so database name I can give glue demo white. Okay, here the tables will be created, right? So database is getting created in our glue catalog. We have to just give little bit time, and that is done. I will go to next, and then here I can finish. Okay, so now what this particular crawler will do, it will read the data from SQS. That is, those files alone it will be crawling which came newly. Okay, no need to crawl earlier files which it already crawled, right? That's how we are crawling incrementally. Perfect, right? So now I can go to queue, and as of now you can see in queue nothing is there. So what we are going to do, we are going to S3, and here we are going to upload some data. And how we are going to upload? We are going to upload the data, or put the data in S3 from Snowflake. Okay, we are going to unload the data from Snowflake to S3, right? So first I am going to drop a database if it exists, and then I am going to create the database, and then here I am using that database, and then here I am creating the table, and the dummy dataset I will provide in the description box or in the comment section so that you can also simultaneously practice. And here we are inserting some data. Okay, now what we want, basically we want to unload this data in our S3. Okay, so if I do select start from books, here you can see 1000 records it will be showing. Okay, so book ID, book name, publisher and author, these are main record, and suppose we want to partition our data while unloading as publish year, and inside publish year it should be publish month. Okay, so that also I'll be doing. So first I will create the file format, and then here what we are doing copy into S3:/ hello world metadata. That is this particular S3 bucket name, whatever we have created here, that one only we are keeping here. And then inside that download is one particular folder inside which we are going to unload the data. Okay, and what is the unload query? Select book ID, book name, publisher, publish year, publish month from books. Okay, SQL query I can put, and then here what I am doing, I am saying partition by publish year partition equal to publish year, and then / publish month partition equal to publish month. Okay, so the folders will be created like first it will be publish year partition equal to some particular year value. Inside that it will be having month partition, and then month value it will be having. Okay, so here the partitioning while unloading, don't confuse with Hive partitioning. Okay, when you partition some data in Hive, then that particular column on which you are doing partitioning, that you no need to mention in the main query, right, main DDL. But here we have to put those columns in the select expression also on which we are going to do partitioning, right? So that's why I have given like this way. And then here we are unloading the data. Here I have created the AWS access key and secret key which is having S3 write access. So not a problem. Now we can run this particular stuff. Okay, let's run that one, and we will see the data will be unloaded soon. Okay, so if you see that total 303 files created, okay, in our data lake. So if I go to data lake, if I just refresh this one, here see download this one particular folder. Okay, inside that folder there are subfolders, partition year wise partition data is stored. Inside that if I go, month wise partition data is stored. Inside that if I go, this CSV file is there. Okay, now all these notifications it will be sending to SQS because we have configured the event notification, right? So if I go to SQS, currently message availability is showing 0. If I just refresh this one, it is showing 303. And why it is showing 303? Because if you see in this Snowflake unload, total 303 files only we unloaded. That's why 303 notification came in SQS. Okay, now what we will do, we will run our crawler. That time the crawler will first go to SQS, it will read all the new files notification, and those notification alone it will be crawling in our data lake. Okay, and as this is first time, so it is basically going to crawl everything present in our history, right? So I can show you as of now. If I go to database, here this is the one, and if I go to tables, currently no tables is there, right? So let's start our crawler. As this is the first time, so it is going to take some time. We have to wait little bit. Okay, so I will start run crawler. Okay, so attempting to run crawler this one. So here eventually what you will see, that when the crawler will start working from the SQS, the message will disappear. Okay, because once a consumer consumes the message, then it is generally message goes to flight, right? And then if the consumer able to successfully consume, then automatically it will delete from SQS so that other consumers should not able to reprocess the same message, right? So that kind of activity we'll able to see soon here also. So here you see it is in starting phase. If I go to SQS, currently messages are there because the crawler is not yet started. We have to wait little bit, and soon we will see that in SQS message available will be 0. Okay, let's wait for a few seconds. So let's see. See, currently message available in SQS is 0. That means what? That means our crawler has consumed all those messages. Okay, soon it will be creating a table in this particular database. Okay, 2 minutes elapsed. So obviously it is expected that it will take some time because this is the first time historical load happening. From next time onwards, it will not call the complete stuff, rather it will just stuff the newly created files. Okay. So here you can see currently it is in stopping phase, tables added 1. That means the crawler has crawled the S3 data and created one particular table in our Glue catalog. Okay. So I can go to our Glue and see here. You can see in the databases, this one here, this is the table with what it has created. Okay, so object count 303 files it has basically crawled, and if you see that publish year partition and publish month partition is created, partition 0 it is not required, it just created by default case. Okay, that is partition 0, it is basically inferring this hello world metadata at this bucket level itself, so that is not mattering that much. So let it be as it is, not a problem. So now we can basically query the data from Amazon Athena. Okay, then go to Athena and let me query some data. Let me first go to Snowflake and see. So if you see this particular query, select start from books where publish year equal to 2009 and publish month is 22. If I run this one, here I'll be getting these 5 records. Okay, let's query from Athena. And this is the database and this is the table, right? What we are having. So I can run this one. Sorry, here I have to change the name. And let's run now. See, here we are able to see the 5 records. Okay, so actually this time what it happened, the Glue crawler basically crawled from SQS. Okay, in SQS currently no messages are there. Okay, and here our crawl is also finished. Last runtime 3 minutes, median runtime 3 minutes, one table is added. Okay, now what we can do, we are going to insert 5 records in our this table. Okay, let's run this one, and the year is 20,300 and 20,200. Okay, and then here if I just query based on the year 20,200 and 300, whatever newly we inserted, we are getting these 5 records. Now these 5 records alone we are going to unload in our S3, and we will see that these 5 now the crawler is processing, or it is processing the complete stuff. Okay, that way we can understand it is working incrementally or not. Okay, so here in the unload command I have written that publish year is 20,200 or 20,300, and rest kept all same only. And then let's run this one, and it unloaded 5 records. So if I go to my S3 in the downloads, here see 20,200 and 20,300 two partition came for 5 records. As you can see that actually total 5 files it has written. So in SQS we should be seeing 5 messages. Okay, so see 5 messages are there, right? And now what we will do, we will see whether in Athena we are able to query the data or not. Okay, so like this kind of query when we executed on 20,200 and 20,300 in Snowflake, we got the data, right? Here we got the data. Now if I go to Athena and query the data by changing the table name, let's see. So here we are getting no data. Why so? Because remember this, like in Athena, whenever new partition is created in data lake, we have to execute msck repair command, or even in Hive also we have to execute msck repair command or altered table add partition, this kind of query, right? Similarly, whenever new partition is created in your data lake, then your glue crawler will not automatically consume that. You have to recrawl the data, okay? That means you have to run your crawler again whenever new partition you want to load, so that the metadata will be up to date and Athena can basically use that data, right? So now the thing is, when I'm going to recrawl, then if I don't use incremental crawl concept, then again from beginning it will be crawling all the data, right? But because I have configured incremental crawling, so this time only it will just take the 5 messages from the SQS and those alone it will be crawling, okay? So I will go to Glue console and I will start running my crawler again. So earlier it took nearly 3 minutes, but now it will be faster, okay? And earlier it created one table, right? Table added one. This time it will be showing table updated one, not table added, okay? Because new table it is not going to add. Just the older table, whatever was created, in that it is going to update the metadata. It will basically make sure that that particular partitions, whatever newly created, that will be in sync with the metadata. So basically it will be updated, not added, right? So I will run the crawler again and hope it will run this time a little bit faster. Let's see. So it started, and as soon as it started, we will see that from SQS soon the message will be consumed. Okay. Let's refresh it and wait for a couple of seconds. See, message available 0. That means our crawler has consumed those, right? Now soon it will be updating the metadata, and then we can again execute the same query in Athena. Then we will be able to see that the newly created partitions, those data we can access. Okay. So if your schema is not changing, or if new partitions are not getting added, then no need to recrawl or no need to run the crawler. Okay. If your schema is changing from source, or maybe new partitions are added, then only you should be running the crawler. Okay. And in the big data lake scenario, instead of running the big crawler again and again across the big data set, what you can do, if you know that the new data is coming as new files only, then you can run your crawler only on those files alone, not the complete data set. Okay, that's what the concept of incremental crawling. How we do incremental load, that way this is termed as incremental crawling. That's it, nothing else. Okay, and see, it is stopping within 1 minute itself. It is showing stopping. Okay, so soon it will be in ready state, right? And we will see that table updated is 1, table added is 0. Earlier table added was showing as 1, table updated it was showing as 0, because that time no table was there. But this time table was there, just the metadata it is syncing with the data lake and the Glue catalog, right? That's why it is showing table updated, right? Try to understand the difference, okay? And then what I can do, I can basically run this particular query again, and this time you should be able to see the new data, whatever we just inserted as incremental one. Okay, see, publish here 20,200 and 20,300. Okay, and this time not only we able to crawl incrementally, but because we configured that way, this time the crawler has taken less amount of time, and this is basically optimizing our whole pipeline, because if crawler is finishing fast, then you can run your downstream Glue job or EMR jobs quickly, and obviously it is reducing the amount of cost also, right? I can show you that also. See, it is actually finished. So I can go to logs and show you. Remove this filter condition. And see, earlier it basically created partitions for 2001 and then 2007, all these fellows, right? 2004 and all. And here it was showing finished writing to catalog. So first crawling was this one, and if you see the second crawling here, see only this 5 partition: 20,200 month 1, 20,200 month 2, 20,200 month 3, 20,300 month 8, and 20,300 month 9. It has not crawled the complete stuff like earlier, right? So that's what basically here it is working as incremental crawling. Here you can see also the number of messages in SQS queue is 5. The second time when we again reran the Snowflake unload to S3, that time the 5 files created, right? And in SQS also 5 notification went. That's what it is showing here, right? So beautifully you can analyze the log and get better feeling also. So I hope you understood this, and by applying this kind of incremental crawling, obviously you can optimize your Glue big data pipeline both with respect to timing and cost. And obviously you can improve this particular pipeline if you want further step, that is you can add SNS notification in the middle. Okay, so suppose if any new file is coming in S3, you want to broadcast that notification, then one particular subscriber can be the SQS queue from which the Glue crawler will read that notifications, and there can be multiple other subscribers also. Okay, so you can incorporate SNS also in this particular architecture and improve to the next level, right? So this is all for this video. I hope you have understood this, and if you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.